On a previous video, I promised you a little look into the System 2 and what it's about and how it's going. So I thought on this video, you can join me on one of the tests. What I'm doing is I'm configuring a couple of boards to do a range test, just to see how far the radio signals travel. So I'll introduce you to the System 2 IO16 board, and you can have a look at those. What you're looking at is a pair of IO16 boards. This is a general purpose 16 port input and 16 port output board. And you probably could think of it as the nearest thing on our older system is the multi-panel. But this is, it's not a multi-panel, but that's the nearest way I can describe it. So you get inputs and outputs. And this board is far more configurable and far more flexible. So I'll just power them up and we'll configure them together. So the IO16 boards can be configured via a serial port, which would connect here, or the preferred method is via Wi-Fi. And in fact, on the screen, I brought up the Wi-Fi interface for each board, and you can see on the left and the right the dashboard for the IO16. And here is the name of each board. So this one, the network name is Mega E8414C, which matches the sticker I put on there. And this one is Mega A1F3F4. And for those who know anything about networking, that's the last 3 digits of the MAC address. So these are connected to my Wi-Fi network. And what I'm going to do is I'm going to add, this is, it's a test board of LEDs to test the outputs. We mainly use them for testing multi-panels, but if I drop it on here, then we can see if an output's working. Here's a button, press it, and you can see the corresponding output lights. The way these are configured, physical ports 1 to 16 on the input are matched to 1 to 16 here on the left side of the input ports. And next to that is the V-port configuration. So when I press button on physical port number 1, it's actually sending out a signal on V-port 101. And what that will do is then send that to whatever is receiving on the network on V-port 101. In this case, the output port is also connected to V-port 101. So when it sees a signal, it will correspondingly light up. So if I was to add this port, port 4 to 101, and save the change, then you would see that that also would now light up, port 101. Let's put that back. And now we're back working as ever. So as you can see, the configuration is dynamically configurable, dynamically changeable. So you can make a change, try it, and if you don't like it, roll it back or store it. And of course, you can just hit the reset to defaults and everything goes back to how it was. In fact, if I press that now and then save, I've now stored in memory, permanent memory, the configuration, which is the default. So what I want to do is configure a little test. And to do a range test, let's see if I can get this in camera. So I'll just talk you through the configuration we're going to set up on the V-ports for the 2 IO16 modules. So if I draw an IO16, we have the inputs and the output. If you're asking what can the inputs and outputs be used for, well, inputs can be switches, block detectors, point position indicators, switches, whatever. Outputs can be, in this case for this board, it's designed for LEDs, so it could be driving a mimic panel or an occupancy display or point position, whatever. But in other versions of the product, they will be driving servo controllers, solenoids, relays, and various other devices around the network. Now here I'll connect a switch. There's my symbol for a switch. And we'll be turning on and off V-port 101, which just happens to be the first default V-port in the system. And I'm going to configure the output to drive an LED. Great sign for an LED. It's not, of course. Let's do that. And that's going to be also be connected to vport 101. So locally on this unit, when an event is triggered on vport 101 because somebody's pressed the switch, then the output will be triggered on vport 101 and it will indicate the LED. And that will tell me that this button is working as I press it. Now, the outputs are configurable so that they can be non-latching, latching, inverted. They can have latencies, delays, hold times, and so on. There's many, many things you can do, but for now, I just want to go over the basics of configuring the test. Now, let's do this as board number 1. Now, when I configure board number 2, and it's an identical product, but I'm just going to configure it slightly differently. So what I'm going to do, I'm going to take the output and I'm going to run it on a cable to the input. And if I have this on vport 101, then every time vport 101 is triggered, in this case this port will also trigger, it will send a signal to its first physical port, which will be port number 1. These are physical ports 1 to 16, 1 to 16, and that will be on vport 101 here. But what I'm going to do there is I'm going to configure this vport for 201. So I'll set that to 201. So why have I done this? Well, it'll be clear in a second. What I'm then going to do is I'm going to take some of these outputs. If that's physical output 1 and I've got 16 here, I'll take 5, 6, 7 and 8 physical ports and I'll put them all onto vport 201. So I'm going to configure 4 ports here, 1, 2, 3, 4. I'm going to give them all the same vport. And that means I'll press this button, vport 101 will be triggered, the light will come on, vport 101 will be triggered via the radio, and then that will in turn, because of the wire, trigger vport 201, and 201 will turn 4 LEDs on back on the original panel, so that I've got a transmission to this board, it's decoding in the vport system, and then it's sending data back saying 201's been triggered, turn on the vports there. And that will mean that I can leave a board on my desk and walk around the garden with another board on a battery and figure out what sort of range I'm getting. And it's bi-directional range at this point because it's got to send data that way and that way to be a successful test or to work. So what we'll do now, we'll just go and configure that on the vports and I'll let you see how we do it. If you were watching this video expecting to see model railways run, then it's probably the wrong video for you. On this, we're just talking about some of the internals and the testing of the System 2 Air. I've started the screen recorder now for the web pages that each of these is serving. So they're logged onto my Wi-Fi network, and the web page on the left is for the E8414C board, and the one on the right is for the A1 F3 F4 board, and they're all currently default. So the board on the left has the switch, and as you can see here, it's coming in on vport 101, and you can see the light coming on because it also is attached to vport 101. So far so good. Now if I attach, just as by way of a side note, an LED strip to this board, because it has the same vport configuration, then the light comes on and goes off. In fact, if I find another, this is an unscripted test, if I find another button and plug it in here, then if I press that, then you'll get the corresponding light on there and on the other. So they are truly transmitting and receiving simultaneously. or so the theory goes. So neither is a master, neither is a slave. They are truly peers in this configuration. So now that I'm going out on vport 1, what I want to do is I want to configure the receiver as vport 101, which it is, and then I want to loop that back. So I'm going to take the test strip off, and where's my cable? Here we go. I'll take a cable and I will carefully put the output to the input. Now, as soon as I do that, well, let's just do it. It's permanently held down on and off, so it's going to flicker for a while. So what I'm going to do is I'm going to tell this to transmit on vport 102. And that's done by going to the input and telling it to go 201, sorry. Save changes. And now that's stopped. So now we are sending data out on vport 101. It's being received here. If I had a light on, you could see it, and then it's coming back in, looping back, and it's now being transmitted on port 201. And the way we can see that is if I set up physical port 5 on the output to 201 and save changes, well, as I press the button, we should start to see a light coming on. Now, can you see it's inverted? Well, we'll deal with that in a moment, but you can see now that I'm having interaction with a configured vport 201. And the numbers I'm using don't matter. You can use anything between 1 and 65,000. So there's lots of room for ports. So I'm going to add port 201 to physical port, output port 6, 7, and 8. And I'm going to save those changes. Now when I release, you can see that I'm operating all 4 outputs on one port. So this is the local test, and this is what's being received by radio to that and back. Now the output's inverted here, so what I'm going to do on this, I'm going to invert the output. Let's try that one first. I'll invert that, save. I'll give it a couple of cycles for the logic to click in. There we go. Now they're all in sync, so I've inverted the outputs. So I press this, vport 1 comes on, vport 1 comes to this, vport 1 goes there, and it now transmits that back as vport 201. 201 is coming through and being decoded by these 4 channels. And the slight delay is because I've set latch times of, in this case, 600 milliseconds. And it's got 600 milliseconds when I release here, and then it's got 600 milliseconds latch time on that as well. And that's configurable. So there is my closed loop test, if you will. Now the next part is to go for a walk and see how far we get with this. So I'm going to hook up a battery, and you can join me outside. Glorious sunlight, and we want to look at LEDs. It's not going to be brilliant for viewing, but we can do the test. Now, this house was made in 1886, so it has pretty solid walls and brickwork, and at the moment it's probably in a room about 7 or 8 meters away. So let's see what we get. Let's give it a chance to start. And if I show you the LEDs, hopefully you can see them. Press the button, and I've got 1 plus 4 is 5. Can you see that? If I try it like this. Is that visible? Clear to me. Let's try it. Can I get this in the shade? There we go. Lights on, let go, lights off. So we're in a good spot there. I guess what I really need is a selfie stick. I don't have one. I'll go onto the tree here. So it's coming from that window that's open on the right. There goes a pigeon. Let's try it in this spot. Press the button. Yep. Hopefully you can see that. Off, on, and off. So we've got good full duplex comms there, or closed loop should I say. It's not full duplex, it's radio. Transmit and then receive. Now there's a lot of trees in the way now and a brick wall. Now I will say with this radio I'm running it at 15% of its rated power. Try again. Yeah. And that's because the way the band works for the unlicensed band I'm on, you have duty cycle requirements where you can't keep pressing buttons on certain frequencies at higher powers. But because of the way I'm doing it, I'm on a band where if I use really low power, I don't have a duty cycle limit. I can basically press all the buttons I want all day long and nobody's going to cry. Right, we've got some trees and we've got, see in the background? We've got all sorts of stuff going on. I'm just going to go here in the shade by this garage so you can see the LEDs. Hopefully they'll work. Remember at this point we're doing a test for, it's for an indoor layout. Yep, 5 on, 5 off. Repeat, 5 on, 5 off. By the way, this is the antenna, it's a helical antenna and it's omnidirectional, but the way I'm holding it now, with the transmitter receiver lined up this way, it's probably the worst way I could do it. It's designed so that you hold the boards are level, would give you the best reception. Right, I'm getting to the limits of the garden now. So we have a little bonfire and stuff. I'm not going to go near the beehive on the other side because they were a bit aggressive the other day. I went to look at them and for the first time ever, they all went for me. So I'll avoid that for now. Right, back in the hedge, see if we work now. We've got some action. On, off. Can you see? On, off. I'll stand with my body in the way and it's still going through my body, and that's because at 860 megahertz it's not bad for going through objects, unlike Wi-Fi at 2.4. So we use the Wi-Fi for configuration and the long-range radio for data. Basically, as soon as you turn it on, the long-range radio is active and working without any configuration on your part. But obviously for the VPort config, you'll want to go in and you'll want to change things around. And the beauty of this is that you can assign any input to any other input or output, and you can assign any output to anything else as well on the VPort system. It's a bit like a virtual telephone exchange, I suppose. So if I was to configure this to VPort 70, press the button, out the transmission goes on 70, and there could be 30 devices attached to VPort 70 that respond, for example, in a route. So you press the button and they all conform. Or if you're running a set of points and you press the button, the first light could indicate that you've requested the change, and this could be from a point position indicator confirming that that point has actually moved back. So I'm a good fair way here from there, and what we'll do is we'll wander around and should we do the front as well, make sure it's omnidirectional and all around the place. Okay, stick with me. This tripod is rather heavy. In fact, what I'll do, I'll go through the building end to end. So then it'll be going through 1, 2, about 7 internal walls and an outside wall as well, to see how it copes with transmission through brickwork. Well, it's a glorious Easter Saturday. I should be doing something great, not well, useful. I'd say useful. This is useful. Over a little bridge. My granddaughter loves to drive over that in a tractor. She's an absolute nutter. She loves trains as well, and she's only 3. Whew. So I'm coming back on the opposite side, and I'm going to go right on the end of the building. Hopefully we shall get a signal here. Now, if you were running an outdoor layout where you were doing things infrequently, I could make it so that we change frequency and increase the output power. This system has a, well, they tell me it has a range of about 13 kilometers in normal mode. I've very much detuned it, but we'll see. Right, I'm going end on through the building. Let's see if we get anything. Yeah, no problem. Off, on, off. Right. We're going to go down the drive, and the drive is down there. So we'll just check it all. Whew. In fact, no, we'll go in the paddock and we'll walk through that. My arm's aching now with the weight of the tripod. This is the spot where I shot the intro and outro to the last video. There we go. Both on, both off. Is that possible to see? Put it in shadow? I don't know. Both on, both off. So it's working here through the building. I'd say this is more of a blog than a presentation. Pretty soon the bluebells will be up in anger, or they've started already. And then what we'll do after, once they've gone, is we'll let this grass go nice and long, but we'll carve out a track for the tractor, a path. Have a look here. See all those feathers? I think that was the buzzard's last meal. We have 2 buzzards in these trees. They're not nesting here, but they do like to hunt in this this field. So they're here every single day. A pigeon, and they're very active in the field. I don't know what they eat. I think I've seen them eating worms before now. So this is the limits of the boundaries of my property, and if you can hear, I'm by the road. So we're going all that way. On, off, on, off. So I think that's a pretty good range test. It's certainly adequate enough for an indoor layout. I did do a test once. I've got 4 floors in the house. I've got a basement as well. And I went down into the basement and it worked there through the floors. So all in all, pretty good. So I'll sign off now as I'm out of breath. So thanks for watching on this behind the scenes look at new products. And I hope to show you more as we get nearer to release date. So thanks for watching, and I'll see you again with the next video.